So the system is now connected, however power is not introduced into the system. Everything is on zero. As you can see here, the ground self-resonance here is around 500. It's about 1 volt actually. When I measure it on the inside of the capacitor, which is not linked to anything except to the primary. So connected is the DMM to the outside and to the opposite side of the capacitor, so the DMM gives me about 120 millivolt. So as you can see, frequency can be adjusted. So that is just a TTL signal. Just a TTL signal from the pulse generator. Right. Now I start this one up. What I have here is a current detector. It's a standard equipment of every electrician to indicate wires which are within a wall, or if a wire carries current. So here in our examples it would be the wire here from a system that's working. So I keep that here. Well, let's put it here. Let's fire it up. So that is now overshooting. Alright, let's have a look. It says something about 300, 400, 500 volt. On the DMM it says 100 volt. That is 100 volt RMS. And you see, quite interesting, it measures the frequency with 174 kilohertz, and the frequency counter is exactly saying the same, so it's quite accurate here. Very accurate, the measurement. Let's see if I can get a little bit more juice out of it. Oh yeah. It's very sensitive. To stray capacitance, and I cannot adjust it fine enough. So let's see if I can get $250. We had it a little bit higher before. So the field is actually going out till here. There's quite a huge field around here. It's quite intense in here. Quite intense, so I'm literally here. On this side, the field is quite small. Of course, the electrical potential is increasing over here, and it's quite huge over here. Let's see on the inbound side, nothing. It starts here. It normally starts over here. Just the first windings, and then it goes out quite strong over here. So the rectified quite nicely. I have now 75 volt DC directly picked up from the capacitor side on the primary of the receiver. And now I can charge up capacitor bank, and we have a look how fast it's going to charge up to this main value. That gives you an indication about the power of the system. I've attached now a 200 volt 100 microfarad to the rectifier. Volt is 0.7. Now let's see how fast this one charges up. Power up. It now the variable capacitor to the ground, and I charge up in the middle. So what I mean is the system get triggered on the receiving side. I pick it up here from one side of the coil, which is connected here to the end. The inside is kept in here, connected to the rectifier, one side, and the other side is connected to the variable capacitor. Now let's have a look on DC. Even with no power on, it's charging up now. I start now my driver. Tremendous amount of speed, it's charging up. We're talking about 200 volt, here we're talking about 100 microfarad. Extremely fast charging up. And the power I currently use, very low. It's 2 watt from 0.4, 0.6, 2.5, 2.6 watt. Charging up to 100 volt, 110 volt. So I have to be careful if it reaches over 200. This one is gonna explode on me. So I'm gonna add a bank now to see how much I can get into a bank, and then I will take out the energy from the bank and drive a load.